This video is going to cover the topic of surface area. Be sure the date and topic are at the top of your page. The essential question to guide our video is, how do we calculate the area that covers a 3D shape? When we think about a 3D shape, there are a few terms that we need to know. The first, and the one that you will hear very often, is face. A face is a flat surface of a 3D shape. In this cube, there are 6 faces. I'll just shade in the one on the bottom here, because there are 6 flat surfaces that make up the shape. The bottom and the top, and then of course the 4 faces along the outside of the shape. When we want to cover a 3D shape, say for wrapping a present, we need to know the area of all of the faces on the shape that we're trying to cover. We call this finding the surface area. In fact, surface area is defined as the area it takes to cover a 3D shape, as if we were wrapping a gift or wrapping a box. We can find the surface area by breaking the 3D shape into pieces. By doing that, we can find the area of each face one by one. I'll show you what we mean by using this rectangular prism that I have drawn. I've included some measurements that tell me each of the edges, which is another term that we use here. The edges are these connecting points that connect each face. I've shown how long we measure each of those edges. So it's 2 by 2 by 6. In this shape, there are 6 surfaces, 6 faces, so we want to find the area of each face so that we can cover each one to cover the entire shape. I've given each face a different name. So the first face I have here is the front, and the front is going to be this part that I can see at the front of my shape. Now this is a square, and so if I want to find the area of this square, I'll simply do 2 times 2, and I'll see that this is 4 square inches. So to cover that front shape, I need 4 square inches. Now the back here is actually the same, right? This was 2 and so is this, and the height was 2, and so it's still 2 in the back. So the back is actually the same thing. So it's again 2 by 2. So again, this is 4 more square inches. I'm going to skip down to the right here next because it's a little easier to see. So I have this panel right here, this face, which is a rectangle that's 6 by 2. So if I want to find the area of that, I multiply my 6 times 2, and I find out that that is 12 square inches. Now, I can go back to my left-hand side now, which is here hidden a little bit back here, but I know that these are identical, right? These opposite sides are parallel and congruent, and that also is 6 by 2, so that is also 12 square inches. Taking a look at the bottom now, I can see that my bottom is right here, right? And it's 2 inches along this edge and 6 inches along that edge. So it's 2 times 6, again, for 12 square inches. And the top, I'll go ahead and just do this in black, the top is identical, right? It's 2 on this edge and 6 inches on that. So 2 times 6, this is again 12 square inches. Once I know all of the areas of all of the faces, I need to find the sum of all of that information. So the first thing I did was find the area of each face, which leaves me to now find the sum of all of the areas. So if I look over here, I need to add all of these values up to figure out my total surface area. The area it would take to cover this 3D shape would be 56 square inches. Sometimes people prefer to use a net to find the surface area rather than the 3D shape itself. And that's a great strategy as well, and the same principle applies. So here I have a net of a rectangular prism, and I'm just going to go ahead and use the measurements that I see here on the grid. And just like I did when I did this without a net, I am going to find the surface area by finding the area of all of the faces, all of the parts of my net. I'll start here with my red space. That space there would have an area of 3 units, and actually this space would be opposite. This face would be opposite in a 3D shape, and so that has the same area as well. The area there again being 3 square units. From there, I can go ahead and look at the faces I have on the left and the right that I've used here in blue. So I'm going to find the area of both of those faces. And it just so happens those are both also 3 square units, or 3 units squared. And lastly, I'm going to take a look at what would be my base and my top, most likely, if I folded this up, and I'll find the area of both of those pieces. So now, as we did before, I have all of the areas of all my individual faces, and so it's up to me now to combine them to find the total surface area. So I'm going to go ahead and record, I'm going to use SA for surface area, and to find the surface area, I need to add up all of the areas of the 6 faces in this rectangular prism. By doing that, I can see that the total surface area, the amount it would take to cover the outside of this 3D shape, would in fact be 30 square units. For your turn, I'd like to look at this story problem version of a surface area question. So Ms. Noel has a desire for everyone to make a cardboard box for a project. It's going to be a rectangular prism, and the dimensions will be 5 inches by 7 inches by 5 inches. And we want to know how many square inches of cardboard we need, so we're trying to find the surface area of the box. You can visualize that by drawing the 3D version. Maybe you draw the net to help yourself, but I would like to know the surface area of the entire box. So I'd like you to make sure you know all of the sides, all of the faces to find the total surface area. And that, of course, is our essential question. How do we calculate the area that covers a 3D shape? And so we've seen a couple approaches that we can use for that, and we'll practice more together in class.